I'm just going over this starter question here real quick. Explain slope of a line. What is it? What are other ways of stating it? How do you find it? So on and so on. Several different things you could have written on this. One of the things I'm hoping that you remember from algebra is rise over run. If you're on a graph, you can find the slope using that. If you're given 2 points, then you can use the slope formula, which is this. Don't confuse the slope formula, and remember that equals m. M stands for slope in algebra. Don't confuse the slope formula with slope-intercept form of a linear equation. Slope-intercept form is that y equals mx plus b, and it actually tells you the slope, that number right there, and that. As far as what it means, slope tells you if the line's rising or if it's a falling line, and it tells you how quickly it's going up or how slowly it's going up. All right, on the homework, the packet, I'll do just a couple of problems off each page, just to give you some idea how to do them. And I'm just going to pick this time. Let's see, we'll go with number 3 on the first page. Number 3, which conclusions conclusions could be used? And they give us this picture. My picture might not be drawn real well. They tell us that this is line B, this is line U, this is T, line T, 1, 2, 4, 3, 5, 6, 7, 8. They say, which conclusion or conclusions could you make about the lines U and V if angle 4 is congruent to angle 1, so we know that this angle is congruent to this angle. Well, the only way that that works, if those two angles are congruent to each other, we also know that together they are a linear pair, so they have to add up to 180. Well, the only thing that works there is if they are both 90 degrees. So we know that this angle is 90 degrees, and we know that this angle is 90 degrees. Well, if that's the case, then we know that T has to be perpendicular to line U, and we also know that T is perpendicular to line V. And if we look down through there, B says, so that's one of the answers, B is, T is perpendicular to line U, and then we keep looking because it said there may be more than one. If we look at D, D says V is perpendicular to line T. That's the same thing, it's just reversed. So the answers for number 3 would be B and D. Number 4, on number 4 on the front page, page 135 of the packet, how can you use everyday meaning? Just one way I thought of, this is our normal picture. If these two lines are parallel, this is our transversal. The way I thought of, sort of look at this, I thought this might be a volleyball court. And if I'm on the volleyball court and I'm standing here, and we win the first game, then in volleyball you alternate sides. So if I'm here, when I alternate sides, I would actually be over here. And that's the same as those two angles right there are alternate interior angles. And on number 4, there's really no wrong answer. It's whatever helps you to come up with an idea to help you remember what alternate means. Second page, let's do 7 through 12 on the second page, and I won't do all the problems. I'll just go through and draw the picture and label everything. So this is for problem 7 through 12 on the second page. You should be able to get the answers once I go through and do everything. They tell us that these three lines are parallel to each other. Our transversal runs something like this. It's angle 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And what you're going to need to do on this, instead of looking at the whole picture, split off two of the lines. Change my ink color here. This green. I'm going to split off these two lines over here, the two parallel lines. I'll try to look at the whole picture as one thing. It ends up confusing you. And they told us, I forgot to label this, they told us that angle 7 here was 100 degrees. So that's this angle right here. Well, then I can go through, since these two are parallel, I can go through and find all the rest of these angles. If this angle's 100, then this one down here is 100 because they're corresponding angles. Remember, if you smash the two lines together, those are corresponding angles when they lay over top of each other. This one's 100, this one up here is 100 because those are alternate interior angles. You also knew that these two were vertical angles. These two angles have to be supplementary because they're a linear pair. Let's go back. Switched on me. That's 80. This angle's vertical to that, that's 80. This one and this one down here are corresponding angles, so that's 80. This one and this one are alternate interiors, so that's 80. This one and this one are vertical, so that's 100. So we know all these angles in here, and I'll just go through and write them. 100, 80, 80, 100, 100, 80, 100, oops, that's 80, not 100. Now if I go to the other side and I split off the other two lines, I know now on these that this angle is 100, that's angle 5, this is angle 8, this one is angle 6, and this was angle 7. And if these lines are parallel, then I can find all these other angles over here. This one's 80 because those are alternate interior. These two are alternate interior, so this one has to be 100. This one over here is 100. These two are vertical, so that one has to be 80. So now I can go through and put in all these. That's 100, that's 80, that's 100, that's 80. Those, and I know that's not too difficult. You probably really don't have to split those off. You can just sort of cover up one side, but I like to split them off to make sure I don't mess up. The ones that you really need to make sure that you split off are ones like in 13 through 18. That's the one I'll do next. So this is for problems 13 through 18 on the second page. And again, on that last problem, you go through and you figure out what the answers of 7 through 12 are by filling them in there. This one, they give us this picture. And they tell us that these two lines are parallel. 1, 2, 3, 4. Make sure I number these right. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And what you're going to need to do on this one, we're going to find all the angles. So again, you're going to have to go back and fill in the answers that they wanted. All I'm going to do each time, I'm going to split off the two parallel lines, and I'm going to pick a transversal. The first time, I'm going to pick this top line as my transversal. And they told us that, I should have labeled these in there. Let's see here. Let me change my ink color. Let's go with the green again. They told us that angle 3 was 75 degrees and that angle 10 was 115 degrees. So I know angle 3 is right here, that's 75 degrees, and the part of the picture that I split off, and I'm just going to find all the rest of these angles. So if that's 75, this one over here is 75 because they're vertical. This one is 105 because these two have to add up to be 180. This one's 105 because they're vertical. This one and this one are alternate interior angles, so it's 105. This one and this one are corresponding angles, so it's 75. This one, this one and this one out here, alternate exterior angles, so they have to be the same, so that's 105. That one's 75 because these are vertical. All kinds of different rules you could use there. Then I'm going to go back and just fill these in. So angle 1 here was 75, angle 2 was 105, angle 5 was 105, angle 6 was 75, angle 7 was 105, angle 4 was 105, and angle 8 was 75. Now I'm going to split off the two parallel lines. Instead of using the top line as the transversal, I'm going to use that bottom transversal. I know this angle is 115. Well, if that angle is 115, then this angle is 115. 180 minus 115. Make sure you don't make mistakes on this. Borrow. That's 565. So this angle is 65, this angle over here is 65, this one and this one are alternate interior, so that has to be 65. This angle and this angle are alternate exterior angles, so that has to be 65. These two angles are alternate interior, so that's 65. This angle and this angle are corresponding angles, so that's 115. And then we can label all those in here. Angle 9 is 65. Angle 13 is 115, angle 14 is 65, angle 11 is 65, angle 16 is 65, angle 12 is 115, angle 15 is 115. You know all the angles. Again, you have to go back and answer just the questions that they wanted you to answer. On this third page, we'll do, I don't know, it doesn't matter, let's do problem 8 on the third page. Problem 8, they give us a picture, it looks like this. They tell us that these arrows, remember, tell us that all three of those lines are parallel to each other. It tells us this angle is 5y minus 4. This angle is 3y. This angle is 2x plus 13. Again, you can't look at this whole thing together, so if I split off just these first two parallel lines, this is a transversal, this is 5y minus 4. This is 3y. Well, those angles aren't anything to each other. They're not any of the special pairs that we learned. But we know that this 3y and this angle right here have to be the same. So we could move that 3y up to there because those are vertical angles. And then we know that these two angles are consecutive interior angles. And consecutive interior angles are the ones that are sort of the oddballs. They have to be supplementary. So 5y minus 4 plus 3y has to equal 180. If you set up some other equation and it didn't come out right, it came out with x's and y's in it, then you just need to go back and try to find an equation that just has one variable in it. Here we collect like terms, 5y and 3y give us 8y minus 4 equals 180. Add 4 to both sides. You get 8y equals 184. Divide by 8. You end up with y equals 8 will go into 18 twice. That's 16 with 2 left over, so y equals 23. Once you know y is 23, if I come over here and I split off these two, this parallel line, use this as my transversal. This angle right here is 3y. Well, 3 times 23 is 69. So I know that that angle is 69. And I have this angle out here is 2x plus 13. Well, those are, remember if you trace them, they form an F. Those are corresponding angles, and corresponding angles have to be congruent. So 2x plus 13 has to equal 69. Subtract 13 on both sides, divide by 2, end up with x equals 28. I think on these problems, all they wanted you to do was find x and y, so those are your 2 answers. Let's do one of the crook problems. We'll do number 10. Number 10 looks like this. That's angle 1. They say this is 62 degrees, this is 144 degrees. Remember on these crook problems, first thing you got to do is we're going to draw in an extra line that goes through that point where the crook is, and we make it parallel to the other 2 lines. So then we can split off the top 2 lines and use this as the transversal. And we know that that angle is 62 degrees. Well, this angle and this angle are consecutive I'm sorry, that's the wrong spot. 62 is supposed to be out there. This angle and this angle are alternate interior angles, so that's got to be 62 degrees. Well, that's this top part of angle 1, so we know part of it. Then if we split off these bottom 2 lines and use this as our transversal, we know this angle is 144. Well, this angle and this angle are consecutive interior angles, so they have to add up to 180. So we just take 180 minus 144. Borrow there. My pen's off. Get 6, 3, 1 minus 1, 0. So that angle is 36. That means this part right here is 36. Well, we want this whole angle. So all we're going to do to find that whole angle is add 62 plus 36. And you get 98, so the measure of angle 1 equals 98 degrees. So hopefully that'll help you a little bit with the packet. Make sure you do the rest of it. That will be turned in. This is your quiz. Find all the missing angles. Please remember on this one. And this second one, please remember to separate them. Draw off the pictures so that you have the 2 parallel lines and only 1 transversal at a time. And you can just draw the pictures and fill in all the angles and the spots where they go. That'll make it easier on you and easier for me to grade. So just fill in all those spots where the angles are. All right, on the quiz, hopefully you did this. If I'm looking at this first picture, I know that this angle right here is 70 degrees because those 2 are supplementary. I know that these are vertical, so that's 110 degrees. I'm going to draw the picture bigger so I can actually do something on it. We know that this one's 70, this one's 110. We know that this angle and this angle are alternate interiors, so that has to be 110. This angle has to be 110. These two angles are corresponding angles, so that has to be 70. That one's 70, then this one up here is alternate interior with that, it's gotta be 70. These two are vertical, so that's 110. This one and this one are vertical angles, so that's 70 degrees, so that's all the answers to the first part. The second part, again, I'm gonna draw off the two parallel lines, and I'm gonna pick this as my transversal first. You got to separate these or you're gonna get confused. We know that that angle's 96. Well, if that's 96, that one's 96. These are alternate interior angles, so it's 96. These two are corresponding angles, so that's 96. If we take 180 minus 96, to find the other angles, we get 84. So this angle out here is 84. This one's 84. These two, that's not a decimal in there. These two are alternate interiors, so that's 84. This one and this one are corresponding angles, so that's 84. So we know all these angles. 84, 96, 84, 96, 84, 84, 96. Now to find the second part of it, we split off the two parallel lines again. This time we're going to use this bottom line as the transversal. And we know this angle right here is 68 degrees. Hopefully you could read each one of those. These two lines are parallel. This angle is 68, this one up here is 68 because they're alternate interior. This one and this one are corresponding angles, so it's 68. These are vertical angles, so it's 68. If we take 180 minus 68, you get 112. So these two angles have to be supplementary, so that's 112. This angle is 112. This one and this one are corresponding angles, so it's 112. This one and this one are corresponding angles, so it's 112. We can fill all those in. 112, 68, 68, 112, 112, 112, 68, and that should be all the answers. Got to make sure separate stuff off. Don't just try to look at the whole picture because you end up getting confused. They shouldn't be that difficult of problems. All right, go ahead and start copying this down. What we're going to cover today, slopes. Hopefully in algebra you learned something about slopes, be able to find slopes of lines, be able to use slopes of lines to identify. Remember, that's a symbol for parallel. That's a symbol for perpendicular. All right, with slope, remember the slope is given, my pen out here, rise over run. You're going to use this if you're given a graph. You can just, on the graph of your line, you can pick 2 points on the graph or 2 points on the line and just count how much you go up compared to how much you go over, rise over run. This is the slope formula. Again, don't get it confused with slope intercept. So this is slope formula. Remember that M stands for slope. M stands for slope in math. Don't get that M confused with measure of an angle when we're using that in geometry. Just make sure you know the difference between the two and you can figure that out. you're going to use this formula when you are given 2 points. So if you're given 2 points on, they tell you 2 points make a line, or 2 points are on a line, then use that formula. Please remember, make sure you don't get this confused, this formula confused with midpoint formula, distance formula, any of the other formulas that we covered. So when you're using that, and also the most common mistake, remember that when you are doing a problem with ordered pairs, your x comes first and your y comes second. The most common mistake that people make is they put their x's on top of the formula here because they get in a rush. All right, go ahead. All right, with these lines, if I'm looking at a graph and I just pick 2 points, so maybe I pick this point right here on the red line, and then I pick this point to find the slope, I just count rise and run. Well, this time I went up 1, 2, 3, and I went over to the right 2, so the slope of that red line is 3/2. And that won't reduce any, and we just leave it that way. You don't change it to a mixed number. Maybe I pick the blue line. Here's a point on the blue line. Here's another point on the blue line. Rise over run. Went up 1, 2, 3, 4, 5, 6. Over 1, 2, 3, 4. So the slope of that blue line would be 6/4. Well, that'll reduce to 3/2. If you notice here, those have the same slopes, and you should have learned in algebra that if two lines have the same slopes, then those lines have to be parallel to each other. Couple other things, if we look at this line, the green line, it's a horizontal line. And the slope of all horizontal lines is always 0. We're going to talk about that here in a minute. And the way I remember that is if you have a horizontal line on the floor is horizontal, I can actually walk across it and I'm going up 0 slope. If you have a line like this purple one, which is vertical, the slope of a vertical line, there isn't one. It has no slope. And again, I remember it because a horizontal line has a slope of 0. I can actually walk across it. A vertical line doesn't have a slope. I can't walk across it. It's impossible to walk across it, so it's impossible to find the slope of it. All right, take a second, write these down. With parallel lines, the rule for parallel lines, they'll always have the same slopes. So if you know two lines are parallel, if I tell you some line has a slope of 2/5, and I say, what's the slope of a line parallel to that? Then the slope's going to be 2/5. The slope's got to be the same. Perpendicular lines are opposite reciprocals of each other. Opposite means you change the sign. Reciprocal means that you flip the fraction over. And we'll do a couple of examples here. If we take that same one that we had up top there, 2/5. Well, if I want something that's perpendicular to that, you flip it over. So you make it 5/2. And then you want the opposite. It was positive, so we're going to make it a negative. Another example, if we know the slope of some line is 3, and we want the slope of the line that's perpendicular to that, well, we got to flip that over and then take the opposite of it. Well, to flip it over, you need to take the 3 and put a 1 under it. So now we have 3/1. Well, we flip that over and it becomes 1/3, and we want the opposite, so it'd be a negative 1/3. Horizontal lines, I'll come back to rate of change in a second. Horizontal lines have slope of 0. So anytime you see a horizontal line, it has a slope of 0. Also with horizontal lines. If I was on a graph looking at a horizontal line, goes across like this, maybe this point right here is, let's say -4, -3. Well, this point over here, we might not know how far out it goes, but we do know that it has to go down -3. On horizontal lines, the y's are all the same. On vertical lines, the x's are all the same. Sorry if you can't read that. So horizontal lines, y's are all the same. Vertical lines, x's are all the same. So if I gave you something like this, 5, 2, gave you those 2 points, 5, -7, told you find the slope of it, instead of going all the way through and using the formula, you could look at it and say, hey, those 2 x's are the same. Well, if the x's are all the same, it's a vertical line, so the slope of this line would be no slope. It doesn't have a slope because it's a vertical line. That only works if the x's are the same, or if it's a horizontal line, the y's are the same, you could say the slope is 0. Rate of change. For rate of change, how a quantity changes over time, all you do is on top you subtract the quantities, and it could be any quantity. It could be money, could be gallons of gas produced by some company, whatever the quantity is. Could be ounces in a cereal box, whatever. So you subtract the 2 quantities on top, and on bottom you subtract the 2 times. So maybe from 1920 till, or let's say 1914 till now. So when we subtracted the times, we would end up with 100 on bottom, because that'd be 100 years. And usually when you're doing a rate of change, when you get finished, you want it to have 1 on the bottom. So 1 year, 1 month, or 1 day, or 1 hour, so that you have it as a basic idea of how much that item is changing over that certain amount of time, over 1 year, over a month. How much did it change over 1 day or over an hour? All right, if I told you that this was the assignment, then that's the assignment. Otherwise, there's actually a worksheet that some classes are doing, and I'm going to work a few problems off of that worksheet. First, we'll start working problems off of page 139. That's the first side of the worksheet. We'll just start with number 1. I'll do like 1 from each thing maybe. Number 1 says determine the slope of a line that contains the given points. They give us the points -1, 2, and 0, 4. To find the slope, all we're going to do is use the slope formula, which is you subtract the y's on top, subtract the x's on bottom. The y's this time, please don't forget where your y's are at. 2 minus 4. If I go this way, this is different than midpoint or distance formula, because with slope, the order makes a difference. When you go from 2 to 4, then you got to go -1 to 0. So you got to do -1 minus 0. That gives me -2 on top, -1 on bottom. If I reduce that down, it becomes, the negatives just cancel out and you end up with just 2 over 1, or just 2. If you leave it as a fraction, that would be fine. If you change it to just a number, that's fine also. Looking at this next section, let's do number 6. Number 6, they ask us to find the slope of line TW. Over on your graph, and I'm not going to draw the whole graph out, you see that there's a point at T and a point at W. Line goes like this. There's a point at T and a point at W. Well, if I just go here to there, looks like I go down 2 spaces. Well, down 2 means a -2, and to the right 1, so that's a +1. That means my slope of TW would be -2 over 1. Again, you could change that to just a whole number if you wanted, make it -2. Either one of those answers would be acceptable. Number 7 uses TW. It says, find the slope of a line parallel to line TW. Well, if 2 lines are parallel, then we know that their slopes are the same. We know that they have the same slopes. So if the slope of TW was -2 over 1, then the slope of this new line is going to be -2 over 1. So that's answer number 7. Jumping down to the next section. Why is my stuff not erasing? Let's go back to the previous slide. Jumping down to the next section, 9 through 12. Let's see, I don't know, let's do number 12. Number 12, they give us -4, -8, 4, 6, 4, -6. That's one of our lines. Then the second line is -3, 5, and -1, -3. I want to find the slope of this one. I'm just going to come out here and do that. We'll do -8 minus, watch your signs here, minus a -6, that's our y coordinates. And then we do -4 minus 4. On top, change that to plus, it leaves you with -2. On bottom, you got -4 minus 4, which is -8. Negatives are going to cancel each other out, and you can reduce that down to 1/4. So slope of that line is 1/4. Slope of this line, we do the same thing, use the slope formula. Y is on top, 5 minus a -3. X's, -3 minus a -1. Change that to plus, that's 8 on top. Change this, that's -3 plus 1 is -2. Reduce that down, you end up with -4 over 1. And it doesn't, the negative, remember, you could put the negative on top with the 4, you could put it on top with the bottom, or you could put it out front. Don't put it on top and bottom though. And we look at these two to compare them. Well, it looks like they are opposite reciprocals, because they look flipped over to each other, and one's positive, one's negative. And if that's the case, then that means these two lines are perpendicular to each other. So these two lines are perpendicular. That would be our answer for number 12. Let's jump down, we'll do problem 14. Problem 14 says they want you to graph a line that consists of the stuff that they give you there, and I'm going to write it down here in a second. Let's draw our X and Y axes first. You'll have your graph there. They tell us the slope is -3 over 2, and it goes through the point of -4, 5. First thing you're going to do is graph this point so you have a starting spot. So we go to the left 4, 1, 2, 3, 4, and up 5, 1, 2, 3, 4, 5. Now with this slope, The negative's out front, so when you're doing your rise over your run, you just gotta think to yourself, all right, what am I gonna do here? Well, the negative can either go on top or on bottom. Don't put it on both, because then that changes the sign. I'm gonna put mine on top, and the reason I put it on top is so that I go down and then to the right, because probably on your graph, if you tried to go up 3, you would run out of graph. So I'm going to go down 3, 1, 2, 3, and then to the right, 1, 2. And I put another dot right there. Down 1, 2, 3, to the right, 2. Down 1, 2, 3, to the right, 2. So I have all those points, and they should all fall on the line, and then I draw in the line. That's the answer to number 14, that line. Number 16, let's do number 16. It says we want to graph a line that contains the point 0, -2, and is perpendicular to, so it's perpendicular to the line that goes through 0, 3, and 2, -1. So the first thing we got to do is find the slope of this line. So we do our slope formula, subtract the y's on top, subtract the x's on bottom, change this to a plus, that's 4 over -2. 4 divided by -2 is 2 over 1, or you could just say -2 over 1, or you could just say -2. Either one of those will work. Since we're going to use it as a slope, we probably want the fraction. So the slope of our line, remember, I'm sorry, that's wrong. That's not wrong, but that's the slope of their line. We want one that's perpendicular to that, so what we got to do is take the opposite reciprocal of that. Well, the opposite reciprocal of -2 over 1, we flip it over, and it was a negative, so now it's positive. That's the slope of our line, 1/2. We draw our x and y axes here. We're going to graph this point first, 0, -2, 1, 2, so that's right there. Hopefully you might remember that that's the y-intercept of the line. We go, our slope tells us rise over run. We go up 1 to the right, 2, up 1 to the right, 2, up 1 to the right, 2. And that would be our line. Remember, this is the line. If we were to come over here and graph this line, then it should come into this line. If let's go through and graph that, I'll change colors. If we graph this line, the other line that they gave us, 0, 3, 1, 2, 3, 2, -1, 1, 2, -1, somewhere about there, it's going to come down through here. And we know that those two should be perpendicular to each other. This red line is just your answer. But just to show you that that other one should be perpendicular to that. The back side of the page. I think there's only really one different problem. Let's do number 7 on page 140. So page 140, we'll do number 7. The rest of them are basically the same. It says find the slope of line NM and a line perpendicular to it. So they give us these points, 2, -4, -2, -1. To find the slope of that, we just do our slope formula, subtract the y's on top, x's on bottom. Make sure, again, you take them in the same order. Change this to plus. That's -4 plus 1 is -3. Change this to plus. 2 plus 2 is 4. So one of the answers is -3/4. We want a line that's perpendicular to that. Well, all we do is take this answer and we do the opposite reciprocal. So we flip it over becomes 4/3, and it was a negative, so now it's gonna be a positive. So those are our two answers. This is the original line, this is the line that's perpendicular to it.